Alright, so last time we started this discussion of surface area in section 14.4. Talked about the fact that there's this general form for finding the surface area, and we had done one example. This general form is taking the double integral of the square root of 1 plus each of the individual partials squared. Alright, so we're going to do another example very similar to the one we did last time, at least it starts out that way. And what we're going to be doing is the portion of 2x plus y plus z equals 8 in the first octant. Okay, so to start with, the surface, if you solve it for z, would actually be z equals 8 minus 2x minus y. And it lies above, because we're in the first octant, a triangle in the xy plane. You might be asking, how do I know it's a triangle? Well, because if we actually let this surface be x equals 0, that is, we're in the xy plane, then we have 8 minus 2x minus y. We end up with y equals, well, negative 2x plus 8. And in terms of, oh, and we also know that obviously we've got bounds at y equals 0 and x equals 0. So our shape actually ends up being, in fact, a triangle. Let me draw it over here even. So we have a intercept of 8 right here. It actually crosses the x-axis then at 4, based on that slope of negative 2. So my line here looks something like this. And I've got the x-axis and the y-axis, namely the y equals 0 and the x equals 0. So I have this triangle right here that we're looking at. And this triangle has vertices. Obviously, z equals 0 in both cases, but this location right here would be x equals 0, y equals 8, and then z equals 0. This one right here is, of course, the origin, 0, 0, 0. And this one would be 4, 0, and 0. So those are our vertices, as we've identified there. The triangle itself has area 1/2 the base, which is 4, times the height, which is 8, or a grand total of 16. And f sub x in our equation is negative 2. And f sub y is 1. Alright, so those are the details that we need to work with in order to find this double integral. So there are two ways we could do the double integral. I'm going to show you sort of a different approach as my first way, and then we'll go back and look at it a traditional approach as well. We have the double integral over our region of the square root of 1 plus f sub x squared, which would be negative 2 squared, plus f sub y squared, which is 1 squared, times dA. Well, this is the square root of 6, 1 plus 4 plus 1, so we've got the square root of 6 times dA, which is just the square root of 6 times the area of the triangle, which we said a minute ago was 16, so this is square root of 6 times 16. Oops. There we go. Or 16 square root of 6. So if you recognize the particular one that we're working with, you can manipulate that to be in that sort of line. Now, if you don't and you work with it from a traditional point of view where we're putting in all of the details, we can go back to our particular region that we were looking at, that triangle. Our x values go from 0 to 4. our y values go from 0 to the negative 2x plus 8, right? That diagonal equation that we've got going on there. And we have the same square root of 6 that we had just a moment ago, and we did dy on the inside, dx on the outside. So when we're taking the antiderivative, we've got negative square root, we've got positive, excuse me, we've got square root 6, and then times y, evaluated at negative 2x plus 8, and then at 0. And then evaluating this, of course, we don't have the square root of 6 really affecting anything, so then I just have negative 2x plus 8 right here, dx.
Hello.
And then we'll integrate this with respect to x. So I have, oops, I don't need that there anymore, negative x squared plus 8x. And we'll evaluate again at 4 and at 0. So this is square root of 6 times negative 16 plus 32. And then, of course, evaluating at 0, we get nothing. So this is the square root of 6 times the 16 that we had from before, and there's 16 square root of 6, again, from a completely different setup anyway. Not setup it, but a different approach by thinking about the integral instead of the area specifically of the triangle. All right, so the homework for this section is not very long, as I told you before. We're on page 936. We're going to do number 1, 4, 7, and 10. And that's it.